Okay, so let's start with today's daily question. So the question is bitwise or of all pairings. You are given two indexed arrays, zero indexed arrays, nums1 and nums2 consisting of non-negative integers. There exists another array nums3 which contains the bitwise or of all pairings of integers between nums1 and nums2. Every integer in nums1 is paired with every integer in nums2 exactly once. Return the bitwise or of all integers in nums3. Okay, so this is the question, and see, nums1 is 213, nums2 is 10250. So the 2 from nums1 will be paired with everyone and their XOR will be taken. So 2 XOR 10 is 8, then 2 XOR 2 is 0, then 2 XOR 5 is 7. So in this way, every integer from nums1 is paired with every integer in nums2 and their bitwise XOR is taken, and we have to return the bitwise XOR of this newly formed array. Similar is the case with this nums1 and nums2. We get this array 2516 and the bitwise XOR of this is 0. And the constraints are 10 to the power 5 for the length of arrays, and the elements can go up to 10 to the power 9. Now, if we see the question, so let's say this is nums1 and there are some element. So this is 2, this is 5, this is 6, and there is this nums2, but there is 4, there is 5, or any numbers, right? So I'll have to, so I will take the bitwise XOR of 2 with each number in this array and write it. Then I will take bitwise XOR of 5 with each number in this and write it here. And finally, I have to return the bitwise XOR of this whole array. Now, we have to think about important properties of XOR. So let's say, let's take a number A. So we should know A XOR 0 is equals to A and A XOR A is equals to 0, right? This follows for XOR. Now, I want to find the bitwise XOR of each element with every other element. So if I do this in, let's say, uh, like brute force manner, so this will have the complexity of big O of n square, which will give TLE for sure, because n is up to 10 to the power 5, and if we go brute force, so this will become 10 to the power 5 into 10 to the power 5, which is 10 to the power 10, which gives TLE. So we have to find a faster way to take the bitwise XOR of x with all the numbers in nums2. Okay, how we can do it? Let's think in terms of bits, right? So if I represent, let's say, x in number of bits, so it will be, let's just somewhat like this, right? The number is up to 10 to the power 9, so it will have at max 30 bits, right? So let's take the first example. Okay, 2, 1, 3. So 2 can be represented as 1, 0, right? And let's take nums2. So represent these numbers also in now in bitwise form. So 10 can be represented as 1, 0, 1, 0. 2 can be represented as 1, 0. So this will be zeros only. 5 can be represented as 0, 1, 0, 1. And 0 will be 0, 0, 0, 0. Right? So let's say I want to take the bitwise XOR of this number with every number. And finally, I will take the bitwise XOR of each of these numbers. Right? Let's say what I'm trying to say is, let's say this is nums1, which consists of A, B, C. And this is nums2, which is D, E, F. So my final array will look like A XOR D, A XOR E, A XOR F, similarly B XOR T, B XOR E, then B XOR F, right? And this will finally be equal to, let's take A or like we'll take XOR of this. So this will become A XOR D, XOR A XOR E, XOR A XOR F, XOR B XOR D, right? Now, if you think about this, D will come how many times in this equation? It will come 3 times because it will pair with A, it will pair with B, it will pair with C, right? Similarly, E will also come 3 times, right? F will also come 3 times. And we know that about XOR, what I told you, A XOR 0 is equals to 0, A XOR A is equals to 0, sorry, A XOR 0 is equal to A and A XOR A is equal to 0. So by this, we can say A XOR A is equals to, again, A, right? Because this will turn 0 and 0 XOR A will become A. So what we can see is if A is XORed with itself odd number of times, it will give A. If it is XORed with itself even number of times, it will give 0. So finally, if we see, D will come 3 times in this equation and it will be XORed with itself 3 times. So D will be present in the final answer. Similarly, E will be there 3 times. So E will also be there. Similarly, F will be there. Now think about A. A will be also there for 3 times. So A will be there. Similarly, B and similarly C. So answer of that will be A XOR B XOR C and XOR D XOR E XOR F. Right. So let's take the given example only and understand from it. Right. Now, okay, so nums one is 213, right? So 2 nums one is 213. To make this bigger in size. That's one. So 2 will be present for 4 times. So 2 will be present 4 times. So it will look like something this, which will give us 0. 1 will be present 4 times. So this will 1 will all, contribute 0 to the answer. 3 will contribute 0. But when we consider for 10, so 2 will give 0. Now for 10, 10 will contribute 3 times. So 10 will contribute as 2. Then 2 will contribute as 2 and 5 will contribute as 5. 0 will contribute as 0. So the final answer will be bitwise or of these numbers. So the final answer will be zeros should not be considered. So we'll get 10s or 2s or 5, which is equals to 8 or 5. And if we can see, 8 can be represented as 1000, 5 can be represented 0101. So bitwise or of this is 1101. So the final answer should be 13. And yes, the final answer is 13. So this is how we get to the answer. And let's take this second example. So nums1 is equals to 1 2, nums2 equals to 3 4. So 1 will contribute even time because there are even elements in this. So 1 will contribute 0, 2 will contribute 0, similarly 3 will contribute 0, 4 will contribute 0. So the final answer will be 0, which is equals to this, right? So this is the basic idea behind this. You just have to find the contribution of each element in the final answer, and that's how we'll get it. So you just have to like put this into equation format, and you can get like 1 will contribute with 3, and then 1 will contribute with 4, then 2 will contribute to 3, and 2 will contribute with 4. So 1 is present even number of times, so this will make 0. 3 is present 2 times, even times, so 3 will make 0. Similarly 4 and 2 will also make 0. So final answer is 0. So now just remains the coding part. Okay. So we will store an answer variable. So we will have nums1 dot size name equals to nums2 size. If m is present odd number of times, then only I will consider current element in my answer. So I will take answer A, XOR it with nums1 of I. And similarly, for the second array, if okay, so like instead of okay, I will make it more optimized actually. Okay, so it is giving correct answer. Now we can observe one thing. M is constant, so this condition will not change. So why not we take it outside of this for loop, right? Okay, this gives us the answer. Now let's just submit it. Okay, so this gives us the correct answer. You can see it is one of the fastest solutions. Okay, so yes, that's it from my side. Thank you.